Assalamu alaikum, students. As you all are aware about the fact that due to the lockdown under the COVID 19 conditions, we people are supposed to use the virtual classroom activities in order to keep the teaching learning process continue. As far as class 10th is concerned, you all are aware about the fact that we have started the magnetic effect of electric current. There we have studied what is magnetic field, and hence Ørsted's experiment. Today we are supposed to start what we call as magnetic field due to a straight conductor carrying current. Since we know that whenever current flows through a conductor, it acts as a magnet. It becomes a source of magnet. Once it acts as a magnet, it produces magnetic field. Let me consider a conductor. Let us say this is a conductor through which current I flows in the direction as represented by the arrow. So from this diagram, it is observed that the current through the wire flows from bottom to top. I will draw a rectangular cardboard shaped figure where I assume that this straight wire passes through the center of this cardboard. If we put or we sprinkle the iron fillings on this cardboard that is around the conductor through which current flows, it is observed that these iron fillings align themselves such that they form the shapes of concentric circles. These are these concentric circles, and it is observed from that diagram that these concentric circles are close to each other, close to the conductor, while as we move away from the conductor, the separation between these concentric circles also increases. These concentric circles actually represent the magnetic field lines for a straight conductor carrying current. So, for straight conductor, I will say, for a straight conductor carrying current, I, the magnetic field lines are in the form of concentric circles. They are in the form of concentric circles with conductor as center of these lines. with conductor as center of these lines. So if I will go at a separation, say at this point, say this is point P. Let the point P is at a distance of x from the conductor. Then what is the magnitude of magnetic field at point P due to this conductor? The magnetic field, or the magnitude of magnetic field at a distance x from the conductor carrying current is given by, you have to remember this equation, B is equal to mu naught divided by 4 pi twice I divided by x, where B actually represents the magnitude of magnetic field. Mu naught is called as absolute magnetic permeability of free space. 4 pi is constant, 2 is constant, I is the magnitude of current flowing through the conductor, and x is separation from the conductor. Now, so this magnetic field, you all know, is a vector quantity. B is vector quantity. That means at point P, it is supposed to have, it has both magnitude as well as direction. It has both magnitude and direction. Now, magnitude at point P, we have calculated at a separation of x from the conductor. It is given by mu naught by 4 pi twice I by x. But what about direction? Since these are circular lines, or these are concentric circles, the direction of these concentric circles will be either clockwise or anti-clockwise. Here in this case, in order to find the direction of these magnetic field lines, the direction of these magnetic field lines is given by, you have to remember the direction of these magnetic field lines, direction of magnetic field lines is given by that's called as a right hand thumb rule. Right hand thumb rule. So what do we mean by the right hand thumb rule? Again, right hand thumb rule, this was my conductor, and the concentric circles were in this pattern. They were in a plane such that the conductor was acting as the axis of that plane on which these concentric circles lie. What right hand curve rule states? It states that in order to find the direction of these concentric circles called as magnetic field lines, the rule states that you have to hold the conductor. This is the conductor. Let me say this is the conductor here. This marker is my conductor. You have to hold this conductor in your right hand. Actually, it is in this direction here. You have to hold it in your right hand. There are two ways to hold it in my right hand. Either I can hold it in this way, or I can hold it in this way. In this first case, my thumb was pointing in the upward direction, but in the second case, my thumb is pointing perhaps in the downward direction. You can check it. But you have to hold it in your right hand such that the thumb points in the direction of current through the conductor. So that means I have to hold it in this pattern. in this pattern rather, I will say. Then the curl of the fingers gives the direction of magnetic field lines. So when I hold this conductor in this direction, it is observed that my thumb point is along the direction of arrow through which or towards which current flows. Then the curl of fingers is such that it here moves inwards, but here it comes in the upward direction. So I will say these arrows represent the direction of magnetic field lines. So this rule is what we call as right hand thumb rule. Right hand thumb rule. Its status that hold the conductor in your right hand such that the thumb points in the direction of current. Then the curl of fingers points in the direction of magnetic field lines. So in this way we are able to find both the magnitude and direction of magnetic field at point P due to the current carrying conductor. Thank you.